Okay, let's first note that mass times acceleration equals force. From this problem we can get the mass. The acceleration is going to give us our differential equation so that we can solve this thing. So what we really need to make sure that we can do is find the force acting on this box. So to do that, we know there's two things happening. There's a force pulling it down. There's a force pulling it down the inclined plane, and then friction is pushing it, trying to push it back up this way. So we need to figure out those two forces. So first let's figure out that force pulling it down the hill. That one's easy. We have to understand that if this angle here is theta, that this angle is theta, and that angle is theta. That's some simple geometry. And just knowing a little bit about triangles, you should be able to figure that out if you think about it a little bit. If not, come see me. I'll square you away in like 2 minutes. Okay? So let's find, and we know that here, we have, that is gravity pulling straight down on it. That is our weight. Okay, that's mass times acceleration. So let's do this one. This light blue. Let's find this force here. Okay? So, and let's call that force 1. That's the force pulling down in the positive direction. If I'm going to call down to the left the positive direction, or down the positive direction. F1 equals, well, that's not the way I want to approach it. I want to look at this theta, and if I go, that's the opposite side, so that would be sine theta. Sine theta equals my force, I'm calling it force 1, that's the one pulling it down the hill, force 1 over my hypotenuse here, which is W, which implies that force 1 equals W sine theta. Okay, so that's that one. And let's look at pushing it up. Many of you have had physics, if you're in a differential equations class, I assume, and you know the normal force. Let's look at the normal force. What color can I use for the normal force? Let's use that one. Okay, so the normal force is going to be this force here, but it's acting opposite to, oops, not that one. Hold on. This is the normal force. It is the one that's acting perpendicular to the plane that you're on. Okay? That's the normal force. And we can find it simply by finding it's acting directly opposite to this force here. It keeps it from being pulled into the triangle there, because we have this force pulling down on it, and it has to have some force pushing back up to keep it from being sucked into that triangle or whatever plane you're on. So we just have to find this one, and that is the same magnitude. This force has the same magnitude as the normal force. So again, we're going to look at this angle, and we'll look at, this is the adjacent over hypotenuse. So we get that cosine of theta equals, let's move my force normal over the hypotenuse, implies that my normal force equals W cosine theta. Now also important to note that for friction we have the force of friction is going to be F little f is equal to mu, our coefficient of friction, again given in the problem. times the normal force. Okay, now that should get you started on this problem to see these forces and set up the differential equation. You still have to do some thinking about what is the initial conditions and what's happening and how are you going to get your final answer. Okay, work on this. Come see me with any questions. Thank you.